For the presentation and explanation of the solution obtained, this project analyzed pavement condition using the International Roughness Index, the IRI. We use data from both the left and the right lane instead of calculation one overall average IRI for the entire roadway. The IRI values from each lane were grouped into 0.5 observations. These group values were declassified into pavement condition states and used to build the transition matrix and Markov chain model. This approach allows us to analyze pavement deterioration patterns and more accurately while considering the condition of both lanes. The result helps us understand road performance and support maintenance plannings for the future.
In this case, it is appropriate to use a probabilistic model. This is because the road deterioration is influenced by several uncertain factors or random factors, as well as common factors as the heat, the climate of the road, and also the amount of cars that pass through that road every single day. A probabilistic model is therefore more suitable than a deterministic model because it allows the use of probabilities to estimate the future state of the road. For this project, we use the Markovian system because it satisfies the Markov property. This means that the future state only depends on the current state and we do not care about the previous state of the road. In our study, roads are classified in three main themes: good, acceptable, and bad states. Using transition probabilities obtained from historical IRI data, we can build a transition matrix and predict future pavement conditions. For this project, we use the RII, which means the International Roughness Index. This number can be obtained with a base formula, which is the movement accumulated over the length of the road. This number is classified into three sections: good, acceptable, and bad. If the RII is less than 1.80, it is considered a good road. If its range is between 1.80 and 2.5, this means that section of the road is acceptable and it has moderate deterioration. Maintenance may be required in the near future. For having a bad road, the RII must be greater than 2.50, which is a significant deterioration in the road, and reparation must be done in a short term.
For the methodology, we started with the original ERI database and selected the road section from kilometer 277 plus 500 to 280 plus 0. This section was divided into 20-meter segments, which allowed us to analyze the pavement condition in detail. Then the ERI values were organized by year and by lane. To simplify the analysis, the data was grouped into blocks of 5, meaning each group represents approximately 100 meters. After that, each value was classified into three states: good, acceptable, or bad. Finally, the changes between these states were used to build a transition matrix, which allowed us to model the evolution of pavement deterioration using a Markov chain.
So now mathematical concept and methods used. First, we organize the IRA data from the left and the right lane in Excel. To simplify the analysis, we group each data into 0.5 consecutive observations. Next, we classify each group into one of two pavement conditions: good, acceptable, or bad based on the IRI values. After the classification, we calculate the transition possibilities between states using data from different years. These probabilities were used to create the transition matrix shown here. The matrix represents the pavement remaining in the same condition or changing to another condition over time. Finally, we use these transition possibilities to build a Markov chain model, which allows us to predict the future pavement condition and analyze the determined behavior of the roadway. Results: the Markov chain prediction in the states good, acceptable, and bad in the left lane are 1, 12, and 12, and in the right lane are 11, 11, and 11. For the left lane, most pavement sections are predicted to be in acceptable and bad states, while very few remain in good states, that is just one. For the right lane, the prediction distribution is more balanced among the three states. The model evaluation is the MDA. The model correctly predicted the direction of the pavement condition change in a 58% of the cases, and the correlation The predicted and observed conditions show a moderate positive relationship. The state agreement correctly classified the pavement state in a 15.30% of the observations. The Markov chain model was able to identify the general trend of pavement deterioration and provide future condition predictions for both lanes. Although the accuracy is moderated, the model helps understand pavement behavior and can support maintenance and planning decisions.
The most important results were the transition matrices and the final projections. The matrices show the probability that a road segment changes from one state to another, good, acceptable, or bad. After applying p to the sixth power and multiplying it by the initial state vector, we obtain the expected future distribution. The left lane shows a stronger concentration in acceptable and bad conditions, while the right lane has a more balanced distribution between the three states. The Erie values represent the real physical condition of the pavement. Lower Erie values mean the road is smoother and in better condition, while higher values indicate more roughness and deterioration. To connect this data with the mathematical model, the area values were classified into three states. These states made it possible to summarize the condition of a road using vectors. Then the transition matrix was created from the changes between states over time. In this way, the real road data were transformed into probabilities that describe how the pavement condition changes.
My conclusion is that this project used RII data and Markov chain model to analyze and predict pavement conditions. The results show general deterioration trends and they demonstrate how mathematical methods can support pavement evaluation and maintenance planning.
In conclusion, this project shows how matrix models and Markov chains can be used to analyze road deterioration in a structured way without the necessity of having to look the data one by one. By using the Erie data, classifying the pavement into condition states, and building transition matrices, we are able to understand how the road section changes over time.
In conclusion, road deterioration cannot be predicted with complete certainty because it always depends on random factors. By using the International Roughness Index or the IRI and a Markov chain model, we can analyze how road conditions change over time and predict a future pavement state. This approach provides valuable information for maintenance planning and helps transportation agencies make better decisions regarding road management.
As a general conclusion, the section tends to concentrate into acceptable and bad states, and this model not only describes the current condition of the road, but also possible future behavior using Markov chains and further analysis.